The heat death of the universe is one of the most terrifying things that we could possibly imagine. To be alive when your star goes out like a candle in the wind, leaving you in total darkness, well, it's not something anyone would look forward to. But even worse than that is to exist long after every single star in the night sky goes out, leaving you in total darkness for all eternity. What's that like? We've got some ideas from astrophysicists, but thankfully none of them involve a burning space hamster wheel. Hi, I'm here with Minute Earth. So how will the universe end? Well, we don't know for sure, but astronomers have some theories based on what they see out there in the cosmos. And one of those theories is called the Big Freeze or heat death. To understand this doomsday scenario, you first have to understand entropy, which is basically a physics term for disorder or randomness. Think about your bedroom. When you make your bed, you're decreasing the entropy of the room. That is, you're increasing order. But as the day wears on, and you take your sweet time getting off of your butt to change into something clean, entropy wins, and your room becomes a disaster once again. Physics tells us that the amount of disorder in the universe tends to increase over time. Things tend to go from order to disorder. And if you were to extrapolate that out to the entire universe, eventually everything would be evenly spread out, and the universe would reach a state of maximum entropy. But why should you care about the state of entropy in the universe? Why is that any of your business? You should care because it turns out that this so-called heat death of the universe is just another Tuesday in the life of a black hole. See, inside a black hole, entropy reigns supreme. Nothing is ordered. It's basically pure chaos. Now, black holes can only get more massive, which means they can only become more entropic. And according to Einstein's theory of general relativity, the entire universe is sort of a giant black hole. Well, not really a black hole, but more like a black void. And like a black hole, the universe as a whole can grow and take in more stuff, like galaxies. And as the universe gets bigger, its entropy increases. There are more and more ways for things to be arranged. In other words, more possible states of disorder. Okay, but why should you care about the state of disorder in the universe? Come on, man. You've got stuff to do, people to impress. Well, you should care because, and this is going to blow your mind, the entropy of the universe could explain why time seems to pass only in one way. You see, if you were to reverse the motion of an unordered system like a messy room, it would appear as though order was increasing. You'd think your mom just vacuumed and dusted because everything seems to be going back to where it came from. But in reality, the system is actually moving toward maximum entropy. In fact, physicists have figured out that if you reversed the motion of anything that is in a closed system, you'd always end up with more disorder. This is why we don't see animals undie, or eggs unbreak, or people unchoke on their food. All of these processes move the universe closer to maximum entropy, so they only happen in one direction. If you reversed them, you'd be violating the laws of physics. So, okay, the universe has a natural tendency towards disorder. But does that mean that it'll literally turn into a black hole? Well, maybe. Black hole thermodynamics, the study of black holes and their properties, suggests that as the universe grows, it will continue to approach the state of maximum entropy until it reaches the heat death. At this point, the universe would have taken in all matter and converted it into radiation, leaving nothing behind but empty space, a big black void. It's worth noting that at this point, a lot of astronomers stop believing in physics. After all, it's at this point that Albert Einstein's theory of general relativity breaks down and his ideas about gravity. Need to be married with quantum mechanics to make something called a theory of quantum gravity. But for now, the idea that the universe will expand forever is still just a theory. That said, there's evidence that the universe is expanding at an accelerating rate. If that continues, then the heat death of the universe could be our fate. How would that work? Well, as the universe expands, objects would drift farther and farther away from each other. Eventually, no object would be close enough to exert a gravitational force on any other object. In other words, everything would be weightless. All of the planets would float away from their stars, and all of the stars would float away from each other. Galaxies would fly apart, and even the atoms that make up living things would fall apart into a soup of subatomic particles. But wait, wouldn't that soup of subatomic particles still have gravity? Yes, but without any mass to pull together, there would be no large-scale structure in the universe. There might be small pockets of matter that collapse under their own gravity, but overall there'd be no gravitational attraction anywhere. Remember, gravity isn't a force. It's the curvature of space-time caused by mass. Without mass, there's no gravity. Now, all of this would happen very slowly. The heat death of the universe is estimated to occur between 10 to the 100 and 10 to the 100 power years from now. But if you were around to witness it, you wouldn't even see it coming. That's because as the universe expanded, light would also get stretched. Visible light would transform into longer microwave wavelengths, making it invisible to all but the most advanced telescopes. Even worse, as the universe expanded and cooled, the wavelengths of light would keep getting stretched and stretched until the light waves were no longer strong enough to stimulate your eyes. In other words, eventually light itself would go out like a candle in the wind. And what happens when the light goes out? Well, you find out. You get to find out because you'd be dead. That's right. The heat death of the universe would also mark the end of life as we know it. Stars would go out one by one, leaving you in total darkness. Your sun would swell up and engulf the inner planets, including Earth. The outer planets would freeze, and then they too would drift away from the charred husk that was once our home. You'd watch from your cold rock as all of the nearby stars go out, leaving you in total darkness. Eventually, the expansion of the universe would rip your planet apart atom by atom. And if you were somehow still alive, you wouldn't be for long. Even subatomic particles have a limited amount of energy, and they will eventually decay into their most stable forms. Then there'd be nothing left, just empty space, a big black void, the heat death of the universe. It's hard to say exactly what would happen next because, like I said, that's when physics as we know it breaks down. But in the end, that's why scientists are still working on it. But hey, if you want to see what might come after the heat death of the universe, check out this video about the heat death of the universe, where we talk about the heat death of the universe. It's over there. Click on it. Go watch it. It's pretty great. Speaking of which, you can also click on the thing that gets you more stuff that we made right over there. And if you want to help us make more videos, you can join our community on a crowdfunding platform. It's a great group of people. We appreciate your support. So click on that, unless you don't want me to keep talking, in which case, I'll stop. Either way, thank you for watching.